going to look at two problems off your MT2 LT9 affirmation. Both of them were proofs. Both of them have to do with parallel lines. This is not multiple choice like it is on when you do on an ALEKS, but we're going to go through the same things you would do on ALEKS. First off, let's talk about what you did right. Got statement, reason, and you wrote down the givens. So that is correct. So I'm going to do the same thing you did to start the proof. We know X is parallel to Y. What I'm going to do is I'm going to mark X parallel to Y on here for me. Okay. We're also told angle 6 is congruent to angle 8. That's given. We want to prove X is parallel to Z. Well, what I'm going to do is I'm going to look at line X. And so, since we know X is parallel to Y, we have alternate interior, alternate exterior. We have all those angles that are congruent. Well, looking ahead, I want to use angle 6. Well, angle 6 is congruent to angle 4. So let's write that down. Angle 6 is congruent to angle 4. Now, why do we know that? Well, we know if the lines are parallel, then, in this case, we have the alternate interior angles congruent. Angle 4 and angle 6 are alternate interior angles. So you have to find that choice. That'll be in the parallel line part. Now, look at what we have here. Let me change the color here. We know angle 6 is congruent to angle 8, and angle 6 is congruent to angle 4. So by the transitive property, that's everything's congruent property, angle 4 is congruent to angle 8. That's the transitive property of congruence. I think they just put transitive on ALEKS. But if they have transitive property of congruence, we can do that. So we know angle 4 is congruent to angle 8. Oh, look at that. If I ignore line Y, what kind of angle pair are 4 and 8? Well, they're alternate interior angles. So it's going to be just the opposite of what we did in line 3. We can say, hey, since these lines are parallel, or since these angles are congruent, that makes the lines parallel. So I'll say, if the alternate interior angles are congruent, that tells me the lines are parallel. And so our statement is going to be what we're supposed to be prove. X is parallel to Z, and we're done with that question. Let's take a look at another one here. And once again, we have two givens, don't we? So let's mark that down. So I'm going to say statement and reason. You're told BA is parallel to CE. So I'm going to mark that there. That's given. We're also told BC is parallel to FD. That's given. Put two arcs or two arrowheads on that one. Now when you did the problem incorrectly, you said angle 6 and angle 1 were alternate interior angles. There's a problem there. Angle 6 and angle 1 are not connected by a transversal. So you can't use that. Everything we do with corresponding alternate interior, alternate exterior, consecutive interior, they have to be connected by a transversal. So let's start here. In fact, to make things a little bit easier, what I'm going to do is I'm going to extend line B8 out just a tad so you can see that. I'm going to extend line EC out just a tad so you can see that. Now, using our parallel lines AB and CE, notice angle 6. And the reason I'm starting with angle 6 is because I know in my proof, or what I want to prove angle 6 is congruent to angle 1. So I want to get angle 6 involved somehow. Well, angle 6 is congruent to angle 5 because they're connected by a transversal. Your transversal BC. So angle 6 and angle 5 are alternate interior angles. So it's kind of like we did in the last proof. So we're going to say angle 6 is congruent to angle 5. If we have parallel lines, then we know the alternate interior angles are congruent. Let's keep on going with angle 5. Now let's use parallel lines BC and FD. Angle 5 is congruent. Is it congruent to angle 1? Sure it is. They're both below the line, and they're on the same side of the transversal. That makes them corresponding. Why did I pick angle 1? Because I looked ahead and I said, oh, I want to get angle 1 involved somehow. So we're going to say angle 5 is congruent to angle 1. If the lines are parallel, the corresponding angles are congruent. Now, if we look at our proof, not at the picture, but at the proof, we know angle 6 is congruent to angle 5, angle 5 is congruent to angle 1. Well, there's angle 5 in both of these, aren't they? So therefore, we know angle 6 is congruent to angle 1, which is what we're trying to prove. So that is going to be transitive property. That's everything's congruent property. Now I've gone over those, but when you redo this, you're going to get something different. So you have to apply your knowledge of what we've learned here, not just repeat what I've done. So you're going to have to engage that brain, and it might be tricky for a while. We just got to keep on plugging away until we get it.